Alright, this video is about multiplying and dividing rational expressions. So this first one we have here, this example is a multiplying rational expressions problem, which rational expression just means a fraction that has variables within it in the denominator. So the first thing we need to do, no matter what, is we always need to factor first. So each of these four parts need to be factored into parentheses. And then once I have these in parentheses, then I can start looking for the same quantity on the top and bottom of the fractions, and then I can cancel them out. So we're going to start by factoring. So I'm going to use this fraction, the top and bottom, I'm going to use the generic rectangle to factor those and show you that, or maybe just the first one, we'll see. So the first one, if I factor that, make a rectangle here, 3x squared in my bottom corner, this minus 4 in the top right. I multiply that together, I get negative 12x squared. And the bottom of my diamond is going to be the middle term, or the x term, so 11x down here. So things that can multiply to 12 and get me to 11 when I add, it's probably 12x and 1x. And now one of these needs to be negative in order to multiply back to negative 12. So to try to make 11 when I add, the 1 needs to be negative. So when I multiply, it still makes negative 12. When I add them together, it makes 11. So I'm going to put those back in the box in either of the openings. And now I look at what the columns and the rows have in common. So I can divide both of these numbers here by a 1, and they both have an x in there. This one, both of those numbers are divisible by a 4. They both don't have an x, so I'm not going to put an x there. The sideways row, they're both divisible by a 3, and they have an x in common. Lastly, on the top, they just have a negative 1 in common. So factoring this top quantity into x plus 4 and 3x minus 1. Okay, so that's where that came down there. All right. So let's look at the next quantity underneath here. First of all, we want to look for what they all have in common. They all have an x term in common. So I'm going to pull out an x term. So you maybe do that over here. Okay. So now if I get rid of an x, I'm going to pull it out, factor it out. I have 3x squared minus 10x plus 3. Okay. Let's try this one without the generic rectangle, just to show you how to do that by kind of guessing around. Alright, so I'm going to look at this first quantity here, 3x squared. Well, the only way to get to a 3 is with a 3 and a 1. And so I know both of these terms have to have an x because those multiply to get me an x squared. Now I'm going to look at this n term, my constant term here, in a 3. So the only things that I can use to multiply to get to 3 are 3 and 1, again. Alright, so I still have the same choices. Now the question is, where do I put the 3? Should I put it here or over here? And then also what kind of symbol they're going to be. Alright, so this means they're going to both be the same symbol. This means they're going to both be negatives. Because that's how I multiply. I have to multiply either the same symbol, both negatives, or both positives to get to this positive 3 when I multiply. But since I'm trying to add the numbers to get me negative 10, they're going to both be negatives. So let's think. Let's pretend here. So I'm going to put the 3 here, the 1 here, and I want to check and see if that works. So if I multiply the insides together, this gives me a negative 1x. If I multiply the outsides together, it gives me a negative 9x. If I add those, that in fact does get me into this 10x. So that is the right way to set up those parentheses. So that is factored correctly. Okay, so I'm going to write that underneath here. I have this term, I have x, factored out in front, 3x minus 1, and then an x minus 3. Okay, so we just changed the first fraction so far. Out of the way so I can scoot that up. Alright, so back to the purple, which was our original problem. Let's look at the top right quantity here. 2x squared minus 6x. Again, look for what they have in common first. They both are divisible by 2, this 2 and 6, so I'm going to pull out a 2. And both numbers have an x attached to them, so I'm going to pull out an x as well. And I'm going to write what would be left over. So 2x squared divided by 2x, there's only one x remaining. My minus 6x divided by 2x will be a minus 3 left over. Okay, so we just factored the top right. And then the bottom quantity here, this is a difference of squares, if you can recognize it. So I'm going to take the square root of each of these numbers, or each of these terms, x, and then the square root of 16 is 4. And they're going to both be a plus and a minus, because the x term cancels out, so they have to be one of each symbol in order to remultiply that to make no x terms. So that's basically the hardest part, is factoring all of these correctly and then just looking for what cancels out. So we want the same exact terms on the top and bottom. They have to be connected to, like, in the parentheses. So this whole x minus 3 is here. There's a whole another exactly like that x minus 3 down here. So I can cross those out because we're looking for the same term on top of itself. For example, 4 divided by 4, that's 1. So I can just reduce those to a 1. Let's see, what else? 3x minus 1, 3x minus 1. Cross those out. I have an x plus 4 and an x plus 4 down here. Cross those out. Something else that's left over, I have this x and this x. Those are exactly the same. I'm going to cross those out as well. So now I'm just going to write what is left. What is left over? On the top there is just a 2. And on the bottom, I have this x minus 4 term. Okay. So that's going to be our simplified answer right here. That's what we're just trying to do, make them smaller. And let's also write, oops, you can't see that. Let's also write what x is not allowed to equal, what these terms cannot equal. And that's when we take the denominators, oops, in their factored form, but before we cancel anything out. So like in this state, before I canceled those things out with purple, and I'm going to set each of those pieces equal to 0. And that's how I'll find out what x is not allowed to equal, since we can't divide by a 0. So I don't want any of these parts to be worth 0. So if I set this x equal to 0, I get my x is worth 0. So that is what we do not want. If I set this quantity, 3x minus 1, if I set that equal to 0, I will get positive 1/3. So if I plug that in here, this quantity is worth 0, so the whole thing would be dividing by a 0, and that's not good. That would be an error. So I have x minus 3. If I set that equal to 0, I'll get a positive 3. If I set x minus 4 equal to 0, I'll get positive 4. And if I set x plus 4 equal to 0, I'll get a negative 4. So all of those terms is what x is not allowed to equal. So give me a second here.